Hello, let's talk about Sig Figs, or that's the abbreviation for significant figures. And in calculations, Sig Figs give you an idea of how precise an instrument is. So precision and accuracy are two different things. So accuracy, like if you're thinking about like a target and like you want to hit the middle of the target, right? So in precision, that's just like how close your measurements are to each other. So like this would be very precise. Everything's shown in purple here, that would still be precise, and we're good. But accuracy is how well it hits the target. So you can determine accuracy separately. So accuracy is how well your instrument's calibrated, but Sig Figs are telling us how close those measurements are going to be together. So if I take a ruler and measure something, I'm going to get this number, and if you take the ruler and measure something, you're going to get the same number. And so it's going to be really, really close. And so that's how precise an instrument can be. And so it's kind of like the more Sig Figs, the more precision is inherent in the instrument, but it's different than accuracy. Okay, and this is also like, a way to describe uncertainty in a measuring device, because the last decimal place of any number that you're given, that's going to be like your estimation. Like you're just going to do your best. You're going to read out every single number that you have on the tool, and then you can kind of give like an estimation for the last. And so this is going to depend on how how precise your instrument is. And again, accuracy is calibration, precision is like inherent in the instrument. So if we're talking about measuring heights of this tiny child, if I took them to like the fair and like I'm trying to figure out how tall they are based on this, like you must be this tall to ride. I know that this is like 48 inches or something like that. And then I have to estimate how tall this kid is. So I might come up with one number. I'm like, maybe it's 24, and maybe you would say 25, and somebody else would say 23, or somebody else would say 20, So that's not very like precise, because like these numbers are changing a little bit. And so this last digit, like maybe it's all 20 somethings, but depending on who you ask, that last number is going to change depending on like the angle they're standing at, depending on like their mood for the day, like, oh, is the baby taller, is the baby shorter, like whatever. It has a lot of variability in the last one. So this is only as accurate as its measurement. It's only got one measurement on here. It's not very precise, Okay. Image on the left here. So it's a little bit better in terms of precision. We've got more lines, but these are only measuring to like the 1 inch. So we can measure, if baby was like maybe this tall, you'd say, oh, someone would say that's 22.5. Maybe that's 22.6. Maybe that's like 22.7. So that last digit, that's going to be your estimation, and that's going to have a little bit of variability in it. So maybe, we can settle on like 22.6. Like take the average. But this one in the middle, this one's going to be the most precise, because we've got not only inches, but we've got like half inches, quarter inches, and down even to like 1/8 of an inch if we want to measure it that way. And if we're measuring it with centimeters, we can get down to millimeters, and we can estimate like another like decimal beyond millimeters. And that's because this one has the most lines on it. So this is kind of like the determinant of significant figures. The more lines your instrument has, the more Sig Figs you have, the more precise your instrument is going to be. So in terms of determining Sig Figs, there's 3 rules for determining how many of those numbers in the number are actually significant. Okay, so our Sig Figs are going to include all the whole numbers, so that's everything 1 to 9, but only certain zeros. So leading zeros, those are not going to be significant. So like anything that comes before the whole number, not going to be significant. So like 0.0005, that's only 1 Sig Fig. And if, like 0010, that's only going to have like 1 Sig Fig, okay? Like nothing before it counts. Those are not going to be significant. So zeros in the middle of the number, like 1.005, that's going to have all those zeros in the middle of the number are going to be significant. Draw a smiley face there. Significant. Leading zero is not significant. So like 1.005, every single number here is going to be significant. So this one's going to have 1, 2, 3, 4 significant figures. And same like, like 101. If you like 101 Dalmatians, it's not the same as like 11. If you drop that 0 and said it wasn't significant, you're saying that those two numbers are the same, and they're not. So even like 101 has 3 sig figs, right? So that 0 in the middle, that sandwich 0, that counts. That is significant. So where it gets tricky is like trailing zeros to the right of a decimal are going to count. So if you have a measurement like 1.00, every single one of these, because these zeros are to the right of a decimal, that's going to be sig figs. So 1, 2, 3, those are going to be sig figs. And similarly, if it was like 10 with a decimal right there, like this decimal tells you that this 0 is counted towards significance. Okay, so when there's decimals involved, just like be on the lookout. Anything in front of it that's not going to be significant, but decimals make zeros to the right of numbers significant. So those are called our trailing zeros. Okay, so here's some practice. Go ahead and pause the video, try to determine sig figs on your own, and then unpause the video and check your work. Okay. So remembering our 3 rules, 250.0, this one is going to have 4 sig figs because we see a decimal, so anything to the right is going to be significant. So all these zeros to the right of these numbers, they're all significant. 250 with no decimal, 250, that's only going to have 2 sig figs because this one is not going to be significant. There's no decimal there, so that doesn't make the trailing zero significant. You got to have a decimal to make it significant. 0.0038 millimeters, all of these leading zeros are insignificant. We're going to have 2 sig figs there. 0.340 milliliters, we've got 1 significant 0 and 1 insignificant. So the leading 0 is insignificant, the trailing 0 is significant because we got that decimal. Decimals change the rules. So 340, that's going to have 3 sig figs. 1.00 grams, this has all 3 sig figs because we see that decimal, so everything to the right of it is going to be significant. And then 39580 with a decimal, this makes all those zeros to the right significant. So we got 1, 2, 3, 4, 5 sig figs there.